Okay, so some of you might have got confused in the previous video. Okay, so here I'll give a quick recap of what all has been covered in the whole series of integration. Okay, so we had started by taking the graph of x square, and there we were trying to find the area under the curve of x square. So here I have that figure. So this is the graph of x square, and now we had two limits. Okay, so we had two boundaries at x equals, the first one at x equals 1, the second one at x equals 2. So here are those two. Okay, so I have those two boundaries, and then we were trying to find this area. Okay, so the area under the curve. So I'll just shade that quickly. So this shaded area. Okay, so I'll just, so the area that I just shaded, we were trying to find this area. Then what we had done is, so after this we had the second step. Okay, so from here to here. Okay, so then what we did was we had divided this shape into a few rectangles. So here we go. So here we had divided the whole shape into 3 rectangles. Okay, but we had seen that this is not a very good approximation. The area of these rectangles were not a very good approximation, so we increased the number of rectangles. So here we go. Okay, so the rectangles are so many that they almost took up the entire area of the figure whose area we were trying to find out, and there were so many rectangles. So there were a large number of rectangles and very thin ones. So then the next we took all those strips or the thin rectangles out, and so they looked somewhat like this. So if you look at here carefully, so we've just taken all those rectangles out, and we've not changed the width of the whole thing at any place. Okay, so that stays the same, which is the difference between 2 and 1. Okay, between the two boundaries. And the next we had cut and pasted, and we rearranged these rectangles to form a single giant rectangle. Okay, so that step is shown here. So here I get my single rectangle there, and again we have not changed the width of the whole rectangle. Okay, we've just changed the height of all these rectangles, just to make all of them equal, but this width stays the same. Okay, next, okay, so now as they had been made of the same amount of paper, if we could find the area of this, we would be able to find the area of this, which would be the area of the whole original shape, right? Okay, so you can track it back. Then we knew this width, so all we had to find was this height, and then we had discussed how this height is the average of all these heights. Okay, so there are many rectangles there, they all have some height, so average of all those heights is the height of this rectangle. Okay, this rectangle here. So then what we did was we actually took another graph here, we introduced another graph, and so here's that graph. Okay, so here's that graph, and here this graph, so here this graph, the original graph, was actually the derivative of this graph. Okay, so that is the relation between the two graphs. And then what we said actually was that if we took the same boundaries here at 1 and at 2, and find the average slope from this point to this point, that average slope would actually be the average height of the average height of all these rectangles, which is the height of this. So this height is actually given by the average slope from this point to this point, and we had seen how to calculate that. Okay, so that so how did we calculate that was actually by taking the change in y, divide that by the change in x. So we had done delta x by delta y, delta y by delta x. Okay, so we have change in y upon change in x, and what we had got was actually the height of this, and then as this delta x is equal to this delta x. Okay, so this is also change in x, which is okay, and the whole thing is same. Okay, this is also 2 minus 1, here is also 2 minus 1. So when we had multiplied this, so this height here is delta y by delta x, and this part is delta x. So when we had multiplied this, we had ended up with delta y only. Okay, and this delta y actually gave us the area under this curve. So that is just a quick recap of what we had covered in all those previous videos, and in the next video we'll continue with the mathematical aspect of integration. Okay, the more technical part of it. So yeah, bye. Hope this video has helped you.